session we'll be seeing how to use Simulink. So in command window we'll just type Simulink. A graphical user interface driven library will pop up. So this is a library browser in Simulink. Depending on the version of MATLAB which we are using, it will have various different libraries as well, like Simscape, Simulink 3D animation, aerospace. In this session we'll be concentrating on the Simulink library. It has various sub-libraries like commonly used blocks, continuous functions we'll be using, and then widely we'll be using or following the math operations like gain, trigonometric functions, summations, products, and various. And we'll be using sinks and sources. In sinks, it's a block which will terminate our signal flow, and source, it will behave as a beginner or the initiator of a signal in our diagram. Like constants, we have constants, ramp signal, step signal, and this will be script driven blocks and user defined functions. So let's get started. We'll click on new file. You can press Ctrl N or a blank file over the toolbar. And then let's start a simplest model design. So we'll be multiplying two numbers. Let's say for example, so we'll be using gain. So before appending, we should collect our all ingredients and then we'll connect them. And then another constant will say. And for displaying the answer, like product of two numbers, to display that answer, we may use either scope or display that are in sync block. We can directly drag that block to the R file, or we can press right click and then add to the untitled, and then we'll connect all the blocks. So directly you can drag in that line, or you can use shortcuts like pressing Ctrl and then clicking. And when you double click on a given block, it will have its own GUI driven menu boxes which you have to fill as per your requirement. So let's change that scope to display so that the product like 5 into 3 will directly have mentioned in that display value. And we'll delete the scope. So when we run it, so basically we won't be seeing the idea how it's performing in that configuration parameter, but let's run for the field right now. So we'll just simulate it, and it gives answer, that is the product 5 into 3 is 15. If you note in the command window some errors or some messages have been produced, this is because we haven't saved the file and we haven't configured the parameters which the Simulink block takes. So let's see the resizing, how we can do resizing. So if some much like large data set you have entered, so you can just drag in that square boxes we see, and you can shape as you want, and then it gives the same answers, like same pattern we'll say. So this is a simplest block diagram driven interface in MATLAB. It gives an ideology how to simulate in a sense. So let's make it again back to 4, and now we'll see how scope functions. So we can drag and we can surf it through our cursor buttons in keyboard, and then again we'll simulate it. So scope, when you double click that scope, so it have by default x-axis as time axis and the vertical axis as the value which you have input. So it gives the product 5 into 4 for all time. It's just like a steady state value or a constant value. So for all time it gives the same value, that is 20 here. 5 into 4, that's 20. And you can zoom in the x-axis or in the y-axis by using that magnifying glass. And we can auto scale it using that binocular black tab. We can see that is auto scale. And that second tab we'll be using it very often, so we can set the number of axes we want, like number of y-axis we want, and the history part. Like it is limited to 5000, but we can remove that level in case we are simulating for longer time or when we configure the parameters. So let's make it more dynamic. So we'll be going to source and we'll choose a sinusoidal block, input block. There we go. And then just double click it. And we'll assign some value. Let's say, let it be 1. And then we'll write like 2 pi f, where f is 50 Hz. So we'll write 50 into 2 into pi. And then we'll say OK. And now an issue will appear. Let's see. So we have given something like one amplitude of 1 and a frequency of 50 Hz, but it gives some distorted random value. So what happened? It's actually the functionality behind the Simulink file we are saying, or the functioning of Simulink file. For a check, let's again see the parameters. We have given an amplitude of 1 unit and frequency of 2 pi f, that is 50, 2 pi 50. So we'll have to configure the parameters, the inside functioning of a block of that page, like Simulink will be saying. So it has some methods, mainly for, like, Simulink assumes any model which will be driven, it's a state model representation. So it is intended to solve a differential equation, be it of ordinary kind or partial differentiation. We'll be using fixed step method, let's say for example, and we'll set it to Euler method, and we'll define some step size which will clear later on. We can choose any method we want, and then single tasking, and then OK, and again simulate it. So it gets adjusted. If you see the time axis, it's from 9.5 to 10. So what happened? So we have seen that limitation, like we have limited it to 5000 points. So let's first change the scale, like 50 Hz. So let's make it simulate for 1 second. So if we again simulate and see, the scale is from 0.5 to 1. So let's remove that limit which we have discussed. And then again we'll simulate it. So there we go. We have given an input of amplitude, a sinusoidal input of 1, and it is scaled with a factor of 4. So whatever answer, whatever solution we are having, we shouldn't blindly believe it. So we'll just verify whether it is 50 Hz. So the spacing between the two peaks should be 20 milliseconds. Yes, it satisfies the condition, that is 20 milliseconds. So it's more or less a faithful reproduction of a signal which we want to see.